Hi, 8th grade. Today we're actually going to do two lessons, lesson 3.2 and 3.3. So we'll start with 3.2, connect representations of functions. By the end of this lesson, I want you to be able to say, I can identify functions by their equations, tables, and graphs. To save time, we're going to skip this first page and go right to the first example. Example 1, represent a linear function with an equation and a graph. A 10,000-gallon swimming pool needs to be emptied. Exactly 2,000 gallons have already been pumped out of the pool and into the tanker. How can you determine how long it will take to pump all the water into the tanker? So we see our pool, and we see that there's already 2,000 gallons in the tanker, and then water is leaving the pool at 720 gallons per hour. So one way to do this is to use the information and draw a diagram that represents the situation, then write an equation. So they show us the whole big bar is the 10,000. That's the total amount of water that needs to be pumped. The 2,000 is how much we're starting with. So the amount of money already pumped is the initial value, the y-intercept. So remember, y-intercept is always what you begin with, what you have to start. So we're using the term initial value. Then we know that there are blocks of 720. We don't know how many there are, but it's going to continue to fill up until we hit that 10,000. And that's the amount of water pumped every hour. That's the constant rate of change. So when you see the word slope, you think rate of change. So we can actually use our y equals mx plus b, because we know the rate of change is 720. So that's 720x. And we know our initial value is 2,000. Well, we want to get our y is 10,000. We want to use up all the water. So that's one way to do it with an equation. And we could use SADMAP and work backwards to solve for h. That would tell us how many hours it would take. Another way to do this is to graph it. So same thing, we'd use the formula. Start at 2,000, that's our y-intercept, and use the slope of 720 over 1. Then we just would follow it across from 10,000 and down to figure out how many hours it would take. Also, we can see that this is a straight line, so that's a linear function. All right, let's try it. As the pump is pumping water, the amount of water in the pool decreases at a constant rate. Complete the statements below, then graph the function. So the amount of water remaining in the pool is how many gallons? So we know we had 10,000, but there was 2,000 already taken out. So that leaves us with 8,000 gallons. The amount of water pumped each hour is 75 gallons. So the equation is y equals 8,000 minus 750. Oh, I'm wrong by that anyways. I hope someone caught it. 720. So that is 8,000 minus 720. So we're starting at 8,000, which is somewhere here. And for each one, we're going to go down 720 and then over 1. So if it was for 2, that'd be down 1440. This is a pretty good guesstimate. Okay. How's the rate of change in this function different than that in the example 1? Explain. They have different signs. Because in the first one, we were trying to add water to the tanker. So we were adding the rate of change. In the second one, we were taking water out of the pool. So we were subtracting it. Example 2. Represent a nonlinear function with a graph. How can you determine whether the relationship between the side length and the area is a function? Well, remember, for a function to be a function, it is every input has one output. So we look at all the x values, 0, 1, 2, 3, 4, 5. These are all the inputs. None of them repeat, so we are good with that. So it is a function. Now we can graph that function. Put the points at 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. The graph of this function is not a straight line, so it is a nonlinear function. Remember, linear means line. Example 3, identify functions from graph. Tell whether each graph represents a function. Well, remember, a function means every x value only has one y value. So if you look at this x value, it only has one y value. If you look at the example, or the x value -3, follow it up, it only has one y value. So we can do what's called the vertical line test. And what that means is if you draw vertical lines, your graph should only cross the vertical line once. So this one's a function. This one I'm drawing vertical lines, only crosses the graph once. So that one works as well. But you can't say that, yeah, it's a function because it passes the vertical line test. That doesn't work. You have to say, yeah, it's a function because every x value only has one y value, or every input only has one output. So let's try the vertical line test on this one. Draw a vertical line. I crossed my function here and here. So it's not a function because for that x value, the x value of -2, it crosses twice. There's -2, 1, and -2, 5. So there, my x values repeat. The x value of 2 has multiple y values. You can see it happens more than once here. So it doesn't pass the vertical line test. Try it. Draw a graph that represents a linear function. What equation represents the function? Well, an easy graph to draw would just be go through the origin, and we draw a straight line. Use arrows. Now the equation, remember y equals mx plus b. So the b is easy because it's 0. And our slope, we went up 1 over 1, up 1 over 1. So the slope is 1 over 1 x. So we can simplify this to just being y equals x. So 1 over 1 is just 1, and we don't need to add the 0 because it's nothing. All right, 8th grade, let's say it. I can identify functions by their equations, tables, and graphs. Moving on to example or lesson 3.3. Compare linear and nonlinear functions. By the end of this lesson, I want you to be able to say, I can compare linear and nonlinear functions. Again, we're going to skip this page and go right to example 1. Compare two linear functions. An auto assembly factory needs to purchase new welding robots. The factory manager has information on 2 different models of welding robots. The welding rates for each model are shown below. How do the welding rates for the 2 robots compare? Well, we can see that this robot, Model T1000, can do 20.8 welding tasks in 2 minutes. And it can do 52 welding tasks in 5 minutes. We want to compare the rates. The rate is the same thing as constant rate of change or the slope. So we're using the slope formula again. And you do, this is our y2, this is our x2, this is y1, x1. So y2 minus y1 over x2 minus x1 gives our constant rate of change to be 10.4. Then we look at model GNX007 to find out rise over run. Rise is 11.2 over run of 1. So the slope for this one is 11.2. So that the second model has a faster rate of change. Find the initial value for each robot. At 0 minutes, each robot has performed 0 tasks. So their initial values are the same. So the data for the model GXN007 robot has a greater constant rate of change or welding rate. So it can complete more welding tasks per minute than the model T1000 robot. So we should probably get the GNX007. Try it. The welding rate of a third robot is represented by the equation T equals 10.8 W, where T represents the time in minutes and W represents the number of welding tasks. How does it compare to the other two? Well, its slope, its rate of change, is 10.8, meaning it can do 10.8 welding tasks in 1 minute. That means it's right in the middle of those other two. It's faster than the T1000, but slower than the GNX 007. All right, example 2. Compare linear and nonlinear functions. A square with a side length S is shown. The table shows the relationship between side length and perimeter as the side length increases. The graph shows the relationship between side length and area. How do the relationships compare? So this first one, this relationship is a function. It has a constant rate of change. It's linear. So linear means constant rate of change. Linear is a straight line. If it has a straight line, it goes up by the same amount every time. It has a slope. This relationship, the second one, it is a function, but it does not have a constant rate of change. It is nonlinear. So nonlinear, no constant rate of change. Linear, constant rate of change. So both relationships are functions. Both perimeter and area are functions of side length. Just one is linear and one is nonlinear. Compare properties of linear functions. Example 3. 2 linear functions are represented below. Compare the properties of the 2 functions. So function A, we can see, remember, y equals mx plus b. So our rate of change, our slope, is 2. And the initial value is our y-intercept. Where we start from, it is -3. In function B, we look at the graph. Its initial value, the y-intercept, starts at 7. And the rate of change, we go down 1 over 2. Remember, rate of change is rise over run. So down 1 over 2. So function A, we're looking at the rate of change first. 2 versus -1/2. Function A has a greater rate of change. Then function B has a greater initial value because we're comparing -3 to 7. So function B has a greater y-intercept, a bigger y-intercept. Try it. Compare the properties of these 2 linear functions. Well, function 1, we can do, let's find the slope first. So this is x1, y1, x2, y2. We use our slope formula, y2 minus y1 over x2 minus x1. So 5.5 minus 1 over 5 minus 2 gives me 4.5 over 3. So I get out my calculator. 4.5 divided by 3 is 1.5. So the slope for function 1 is 1.5. And in function 2, it's easy to see because remember y equals mx plus b. So for function 2, m is 2. So the rate of change or slope, rate of change is greater for function 2. Okay, well, we don't just compare the rate of change, we also compare the y-intercept. So remember, the y-intercept is when x equals 0. So we have to go back twice here. Because if we go back once, we'd be at 1. We go back twice, we'd be at 0. But now we know that it goes up by 1.5 each time. So to go backwards, we can subtract 1.5. So when x is 1, this is going to be -0.5. And when x is 0, this is going to be -2. So the y-intercept, or the initial value for function 1, is -2. And we look here, the y-intercept is -4 for function 2. So the initial value, or y-intercept, is greater for function 1. All right, let's say it real quick. I'm running out of time. I can compare linear and nonlinear functions. Have a great day.